So I had another extreme breakthrough with my project. As you know, this is a perfectly tuned, very simplex Slayer exciter circuit, but it's powering a perfectly constructed miniature Tesla magnifying transmitter. I'm going to be having very detailed schematics on how to build this thing. It's very simple. It's just a simple Slayer exciter, and it's run by this chip, a 3 megahertz 1943 2SA 1943 transistor, and you can get them to turn off and on at any frequency you want. I chose 3 megahertz. It's about $10 for a pack of 10, or sometimes you can find them $5 for a pack of 10. And the breakthrough with this technology is you don't want any arc discharges off of your device, because that's a form of energy loss and it detunes the system. You want to coat it in some kind of clear material. As you can see, it's coated in multiple layers of Gorilla Tape to prevent electrical discharges, because a real Tesla coil is not a big spark machine. A real Tesla coil activates most or all devices within its bubble of influence electrically, regardless of how much power it draws, and I've proven that in other videos. And if you properly ground your receiving device, you will get free energy. And the breakthrough I had is I don't need coils anymore to receive a lot of power. This is literally just, I taped it here, it's literally just a specific diode arrangement to form an antenna. You can see this. As far as I know, I'm the only one to have discovered this, and I'm able to get such high power levels out of it. It's kicking out about 3000 or 3500 volts DC at about 20 milliamps. And that calculates to 40 watts of power. Like, I'm not joking. This technology has become so simplex, it is mind-bending. And I can run with it a 50-watt LED light bulb. It's much bigger than this other little light bulb, which is only like a 9-watt one. I have the box for this one somewhere. So as you can see, the big size difference. And there's no trickery or anything. I don't do any form of trickery. I work 40 to 50 hours a week. The pursuit of this technology is my goal. Once you have certain construction principles in mind with it, and you build things in the proper ratios, you will have stunning results, and you get it perfectly tuned. So, as you can see, it's literally just a chain of diodes like this. It's almost similar to an Arvamenko plug. This little guy probably puts out 200 or 400 volts just bringing it near the transmitter. And the interesting thing is, the current will be about 5 milliamps on just one of these. And I didn't even think this would happen, but when I chained all these together, my current and voltage went up, which shouldn't have even been possible, but it is, and I'll show you the results. So this just sits. I just had to put this up on a stand to receive the most amount of power. Like, this is literally just the diodes taped to an empty stand. Like, there's nothing in here. And I'll even open this box. Like, it's literally just an empty box. Like, it's literally just empty. There's nothing in there. You can see through it. So, there's nothing under the tape. It's literally just needed to make a stand. So I'll put this right here next to the coil. Here's the huge bulb. The system runs off of 24 volts DC at about 1 amp, plugged into a watt meter so I can monitor the draw, and I'll turn it on and I'll show you what I'm talking about. There it is. And it's highly sensitive to tuning. Oops, see, it went out. And this fluorescent lights up just being on the ground near it. So we'll try to energize this again. I was messing with the tuning to show you how it worked in the video, so that's probably what screwed with it. It will activate dimly, but that's not the correct effect. Come on. There it goes. Full illumination. 50 watts. That is extremely bright. 50 watts just from diodes. A special diode antenna arrangement. We are lighting a 50 watt bulb, 50 watt LED to over its brightness level, and we are consuming 30 watts. And keep in mind, I can go up to 100 volts DC, at less than 1 amp on the DC input to feed this. I just need to get a DC power supply that outputs 100 volts, anywhere from 0 to 100 volts at less than 1 amp. And I expect to see even more significant gain. Basically what's going on is we've set up an arch form for free energy manifestation. And I will show, hopefully I can pick this up without detuning it. Look how bright that is. Like, that's insanely bright. 50 watt bulb, fully lighting everything up. And it's literally run just off of that little diode chain, and I'll move it and it will go out. And then everything else ignites. Literally just run off that little diode chain. This is my discovery. It's remarkable. It's simplistic, because everything in the universe is simplistic. Most of modern science is probably wrong. So to initialize it, I gotta tune it again. There it is. And we still have intense wireless range. But yeah, this is my discovery. And it's so bright it's drowning out the light of the other little LEDs. And if I can get this tuned even more, I can get it to about 25 watts power consumption and still have the bulb at full brightness. I'll try and do that. It's really picky to do. I'll try it one more time, and if it doesn't work, then I won't do it on video. Dropped it. Try it one more time. There it is. Full brightness. God, that's bright. Try and tune it. There we are. 26 watt power consumption. Still the same brightness. But it's probably more sensitive to tuning. If I bring my hand near it, it'll probably go out. Okay. And I'll show you the amount of power coming off those diodes. Like, look at that. That's the raw output from just the diodes. Like, that's mind-blowing. This is kind of messing with the camera. I'll get these out of the way. And the range on fluorescence is still incredible. And I'm not even running the system at over 24 volts DC. I could crank it up to 100 if I wanted. I just need to get the proper power supply. Still ignited that far away. Now we are going to show you on the meter the voltage and current. I just don't want to fry this meter with the high voltage. So here's the voltage that's coming off of the diodes. It's about 3 kV. Just off the diodes. Like, we can follow the wires. Just off the diodes. Like, how that's even possible, I don't know. Full brightness. And I can also run regular bulbs just by holding them, bringing them near the device. The center of the diodes is hot too inside this. Full brightness again. I notice when you leave it disconnected for a bit, and then you connect it suddenly, you get a burst of power. So yeah, I'll show you the voltage reading. Hopefully I don't fry my meter, because the meter can only go to 1,000 volts, and I'm putting probably 3,000 or 3,500 through it. So here's the meter, and we'll do a, yeah, it's glitching the meter, but it's 3,000 volts. See, there it is. I don't want to break the meter, so we'll go to current. I mean, you saw the arcs, it's over 3,000 volts, and we're at 19 milliamps. Climbing. It will climb on different times of day. And it's real current. 3,000 volts. So if we do 3,000 volts and we play it on the safe side times 18 milliamps, that's almost 45 watts of power, which can do real work, such as running a 50-watt bulb. And I did touch this one time, and it made my whole arm go numb. Just show you some of those arc discharges. So there's no doubt that it's 3,000 volts. Like, look at the length. It's literally coming straight from diodes, that power. How crazy is that? And I could keep going with the chain. I don't even need coils anymore. I don't even need pickup coils. I can just use those diodes. 1N4148 diodes. I'll start the system again. There it is. Full brightness on the bulb. Very bright. Over 50 watts of power, lighting up my whole room, and my cat's chilling on my bed. All that power in the palm of my hand. And I could just keep going. When I increased the voltage, the current also increased too, which didn't make sense to me. We should be getting an exchange of both. If we increase the voltage, we should have a decrease in current, but that's not what we're seeing here. We're seeing a gain in both with the diode chain, which is baffling. So, hopefully I didn't destroy my meter. I'll show you the voltage on this little thing, which got me started to make that big diode chain. So I'll connect that up. and I'll show you. It's so tiny it's hard to connect to. Bear with me, I just gotta get it hooked up. As you can see, we're hooked up to this little thing now, and it goes to the meter. And as you can see, we have voltage. I'll get it close to the coil, and we have very high voltage. Like, that's insane. And it's literally just that little diode key thing. And I will show the current on this little thing. So this little pickup is giving us like less than 1 milliamp. You see what I'm talking about? Less than 1 milliamp at 400 volts. Back to voltage. I bring the little diode chain near the voltmeter again, increase in voltage. So as you can see, this little diode chain, when you combine them in a huge chain like this one right here, it will increase your voltage and your current somehow at the same time. And here's the proof of that. There's some type of effect going on. It's either the extra energy gain is either coming from the sun, the stars. It could even be 0-point energy. I don't have all the answers, but I do know this stuff works if built correctly, using certain semiconductor technologies and certain ratios. So I'll show you the current again coming off of the meter. Here's the current coming off the diode chain. Like, you can see the arcs. And I could just keep going. My voltage off that diode chain can exceed the voltage the Tesla coil is giving off. So almost 20 milliamps. And we'll play it safe and say 18 milliamps. All this technology is voltage driven, not amperage driven. Like, look at that. That high voltage is not coming off the Tesla coil. That high voltage is being induced into the diodes somehow and creating that power. And I could just keep going with it. And it glitched my meter. My meter shut off. I really don't want to blow this meter. Yeah, it's glitching everything on the table. I'm going to give the meter a break. So I'll clean the workspace up a bit, put the meter back here. Everyone in their videos has a messy workstation. I don't want a messy workstation. You can't tell what's going on in some of their videos. So I'll run another bulb. Can never find the right one when I do a video. This is one. This one gets insanely bright. I might have to retune. There we are. There it is. Insanely bright. Still less intense than the big one. I can just pick this up and walk away with it. and it will go out. Oh, we're still lit, we still have the range. Now we're back, going out. Now we're lit. As you can see, it's literally just, there's nothing in here. It's literally just the diodes. Ah, that's getting bright. And we're doing that while lighting that wirelessly. This is literally breakthrough technology. What else was I gonna run? I was going to run, I can't think at the moment. There's a light that I can get really good range with. I think it's this one. So this is insanely bright. And I'll show you the range. Like, this is without even coils anymore. I don't need coils. I can just use diodes. Like, look at the range. And if I made the diode chain bigger, it would increase the voltage and current, and I could get the range even further. How simple is that? And the other thing I wanted to show is when I connect this to a capacitor, things get even crazier. I'm going to connect this to a capacitor, and everything is hard to do one-handed. So here's the capacitor, not connected yet. Now I will connect the capacitor. I can connect just one leg of the capacitor, and it will create charge. So here we go. Like, look at that power. Interesting, now that it's connected to the capacitor, it is putting out the LED lights that run wirelessly. I think the capacitor is detuning it. But it seems like there's more power present. Seems more energetic. And we're consuming 28 watts, less than 30. I will dead short the capacitors. See what our power goes to. We are drawing almost no power. So it's a matter of tuning. You see that? I just moved a few things around a little, and we have more energy now. And we're consuming 26 watts. I'll try and run a bulb off that. I'll connect that to a bulb. Extreme bright intensity. Sometimes the bulb even wants to light with just one wire. Like, can you see this? The bulb is igniting sometimes with just one wire. I'm not sure if you can see that. See that? The bulb is lighting with just one wire. If I ground the bulb, it will light. I don't have a long ground rod on me, but if I ground this bulb, it will light without draining power from the system. Bulb is lit with one wire, as you can see. The one wire power transmission is now present. We get it initiated, and there it is. One wire power transmission. Bulb is still lit wirelessly just by being near the coil. I mean, just by being near the wire. Interesting. Notice it doesn't light when I bring it near normally. Okay. Wireless pickups are still lit. Very bright. This can also light wirelessly, the big industrial bulb. Dimly glows. This is magic technology, guys. Let's see if it can run. It's a more difficult bulb. I'm going to try and run this one. Everything is going wrong when you try and film too. Okay, there it is. It does want to light. You got to get it just right. And it will get... Ooh, that gets very bright. That is some kind of radiant energy. Oh, that is bright. While we have still very good wireless range, this system magnifies energy. We're consuming 26 watts of power, 26.6. Voltage being driven to the system's 24.3 DC. Transmitter. Everything else is a receiver. I'm just having too much fun. So I got that going. Fluorescent tube lit way over here. Try and lean you up somewhere. Fluorescent tube lit. Pretty good distance, about 8 inches. Bulb lit, max intensity. These lit. This is lit. You just can't really see it because it's being drowned out. There we go. All this technology. I don't like the really sparky technology, but I like it when everything runs silent in solid state. I'll try and run the big bulb. No go on the big bulb yet. Okay, it's dimly lit. Oh, it did get really bright for a second. Let it charge up for a minute. Yeah, the big bulb, it's almost like it can't run off the capacitors for some reason. Not as easily. Oh, okay, we got it fully lit for a second. I wonder if I do that trick again where off, I turn everything off, I turn it on really fast and wiggle things around. There it is, okay. Nope, it goes out. So the capacitors don't help in this case. I can't even disconnect it. Everything is going wrong. There we go. Disconnect everything. Come on. Everything's a struggle. This junk out of the way. These bulbs out of the way. I'll try running this again. I swear, it's like you start filming, everything will fight you. Off and back on. There it is. Nope, detuned. So you can spend hours messing with this stuff. There it is. I'm not going to touch it. 50 watts. And I'll get this huge tube too, which you've seen in other videos light up. Huge tube illuminated. From something so tiny. Put this back. So I'm going to turn the light back on. Give a quick summary of what's going on again. This was breakthrough technology again. This is literally what runs it. Just that chain of diodes that are taped to a little stand. These are the receiver coils. You've seen them in other videos. I'm going to build another one of these out of, I use 32 for this one. I'm going to build the next one out of 34 gauge wire. Anything else gets too small. I cleaned up the circuit. As you can see, it's a lot cleaner looking and simpler. It's connected right to that tap for tuning. Kind of see how it looks. Pull this down here. There's nothing under the heatsink. It's literally just a heatsink. Big chip just screwed to it. It's this chip. Just screwed to a big heatsink. The resistor is really what tuned it good too. This is a 54K resistor. The resistor helps tune it and protect your transistor from blowing up. But this is a beefy transistor. Like, this thing is mildly warm. I was thinking of making it even better by getting a little bit bigger heatsink and having one of those peltier modules that turn heat to electricity and having it mounted to this thing somehow and loop it back or capture that energy as well. And yeah, this is what the wireless coils look like. String of LEDs. You have to have the 1N4148 diodes coming off of every coil to receive the power, because without those blocking diodes, you will not receive the power. Your system will be detuned. I've showed that in way older videos of mine. So anyone copying this stuff, you have to do exactly as the way I do it, or it will not work. I've had a lot of people complaining. A lot of people have been harassing my email too. I was even thinking of setting my channel to private because some weird companies were contacting me as well, just harassing and trolling me. I'm not sure if I'll set my channel videos to private or have it so only subscribers can see what I post, but this technology has become so simplex, so refined, and so amazing, it's mind-bending. Like, if I had that diode chain, if I doubled its length, I'd probably get 40 milliamps at 5 or 10 kV, which is mind-bending. Like, I'm still not sure how that's working. I'm telling you, it's tapping into some kind of zero-point energy. Or it's tapping into extra energy from the sun. I'll turn it on again and show everyone. There you go, look at that. Plasma. And it's heating up the wires. Plasma, and we still have wireless. I think I blew this bulb. This bulb got blown. This bulb is not working right. What is going on? Okay, that's weird. There it is. Full intent. Ooh, it went out. Anyway, you've already seen the bulb run. You've already seen all that. I blew one of my favorite bulbs. A lot more experiments to be done. It's still lighting up stuff pretty good. This is a breakthrough video. It's basically just a Slayer exciter circuit with a big 1943 transistor, and instead of the crappy inefficient diodes, I use the 1N4148 amplifier diodes. That's literally a Slayer exciter circuit. That's all it is, with my own personal touch. And it's extremely powerful. And note that it won't work if you don't get the correct resistor value and if you don't have it tuned right. Like if I go to this tap, nothing turns on. I suddenly connect it to this tap, everything will turn on. This is how sensitive these devices are to tuning. Tuning makes or breaks the system. And you have to have a 3 megahertz transistor. So I'll shut it off. Oh, and I'll show you the other interesting thing that's to note. If I can get it into a state of like super resonance, I can light all this stuff on very little power. I'll try and show that. It's also not my most efficient light bulb to run. My most efficient light bulb just burned out. So we are consuming 1.8 watts, inputting 6.3 volts. We still have wireless power. Receivers are still functioning. How much more efficient can we get? .6 watts. 1.7. I had that up to 0.5 one time and it was perfectly tuned. See a little spark down there. But yeah, this video has gone on long enough. I'm going to disconnect everything, show you guys some more of what's up. The diodes aren't even warm. It's remarkable technology. Literally just a string of diodes, daisy chained. We'll disconnect the power supply. Get a good look at all this. Bottom of the secondary connects to the emitter. I'll have a schematic soon. This is a quarter the size, and the primary is adjustable. I show that in other videos. You can see the ring is completely tunable, that black ring. So primary, secondary, extra coil, and the extra coil is connected to the secondary right here with this little bit of heat shrink. And yeah, I'm not sure if I'll set my videos to private or not. I have been getting harassed by a lot of people and companies. A lot of other people have replicated my work, and they're seeing startling results with over unity. Especially when you ground systems in a certain way, you can literally set up a higher potential and suck energy from the ground. But yeah, more to come probably, and I'm not sure what I'm going to do with my channel. Depends how much more harassed I keep getting. But yeah, happy experimenting, guys. Good luck, and don't get discouraged if it doesn't work the first time you build it. It's very sensitive to tuning. And I'll give you another look at it. It's about time other people carried the torch for this type of magical technology. And yeah, alright. Peace out, everyone.